Eye of the Tiger.
Interesting.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 144. Today we're talking about jigs, and more jigs, Faberge mics, paranormal electronics, and a 60-tube Nixie clock. News this week, Elliot, that the root keys for the PS5 have been dumped, which is kind of the first step to running your own code on PS5.
That's awesome. I don't even have a PS4 yet.
I have a PS4. I think it's a pretty good gaming device. It's not something that I've really thought of jailbreaking, though. And when we look back at this, so this PS5 news is coming out of Fail Overflow, who published it on Twitter. And I am familiar with them for running Linux on PS4, which I guess would be something that would be interesting. Fail Overflow did a talk at Congress on that way back, 2015. And then also did a hard mod Nintendo Switch. So on the one hand, I think I can get a pretty powerful Linux machine for less than the cost of PS5.
Right.
And, the mod chipping stuff that I have done historically has been driven in the battled times before there were easy ways to connect a networked computer to your TV. And because I was recording with Myth TV over the air TV, like a roll your own open source DVR. But then you don't want to watch it on your computer that's in, your office. You want to watch it in the living room. And so back in the day, you could mod an original Xbox and then run the open source Xbox Media Center on it and play video over the network, which sounds completely normal these days. But, 15 plus years ago was novel.
Well, do you want to talk more about the hack first before I go off on a random tangent?
I'm not sure there's news about the hack. I mean, we just kind of know that it's coming. So there's a jailbreak. It's kind of out in the open. And I would imagine
it's been leaked that it's happened, but we don't know how yet.
Yeah, I mean, so the thing is, once you get those root keys, it's kind of game over. So the question is, how did you get those root keys? And I think the last that I read about it, I actually haven't read Jonathan's write-up in Weekend Security yet. So maybe he explains this. I'll have to go and look that up after the show. But the last I read, it's suspected that there is a kernel exploit that allows you to get control of the system and then dump the keys.
Cool. Yeah, I was reminded of an old talk and kind of paper/study by Michael Stile. Linux is Inevitable, it's called. And his point is he goes through the hacking of a whole bunch of consoles. And this is back in 2010, I guess, from the PS2, the GameCube, the Xbox, the iPod, the DS, the PSP, the Xbox 360, the PS3, the Wii, etc., etc. And the reasons they were all hacked was basically to put Linux on them. And the one that didn't get hacked for the longest time was actually the PS3. And that's because when it came out, Sony would let you run Linux on it.
Yeah,
and so if you look at the time to being hacked on all these, it's like 3 months, 12 months, 1 week, 2 weeks. And then if you look at the PS3, it's 4 years. Because nobody ever bothered to hack the PS3 until Sony was like, yoinks, can't run Linux on it anymore. And then we're like, yeah, okay, fine. Now we have to hack this box.
I just remember supercomputers clusters being built out of PS3s because you could do that.
Right? I think it's a really neat idea that being able to run your own code, being able to run Linux on it, or being able to run homebrew games on it is the reason that all of these boxes get hacked. The problem, though, is this last column on the table he has there, which is kind of what the long-term effect of the hack was. And in basically all of them, it's like pay TV decoding, piracy, 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 and piracy. Mm-hmm. And this is such a bummer because all of these companies are putting out really good hardware and trying to prevent you from running Linux on them. And it just makes us want to hack them. And so we hack them and we put Linux on them. And then because we did that, some asshat out there then takes advantage of it all and uses it for broad-scale piracy, hurting the interests of the people making the hardware in the first place. And his point, I guess, here is that we should really close this loop and figure it out. And that thing where Sony let people run Linux on the PS3 is actually the way the world should work. And they should just let us do what we want with it, and then we won't have to break it. It's a lovely write-up. It's a little bit dated, but actually, given this news today, more contemporary than ever. I'll throw the links in the show notes.
This is a journey into sound.
What's that sound?
What's that sound?
Last week's What's That Sound? I'll give it up. It was a little bit hard. This was one of those, Mike, you called it. It's one of those where you either know it or you don't. This particular track is one that either burned its way into your brain or it did not. And I think it's an absolute classic myself. It's on my top 10 list. It was Teenage Mutant Ninja Turtles from Turtles in Time. This was the sewer surfing theme, in case you're really into it. They're down in the sewers on surfboards trying to get through, and they're playing this music in the background. It's so rad. It's actually been covered like a million times by guitar shredders on YouTube. So if you want to go hear other people play this, it's like, I don't know what. This was the mid-90s, right? So it's a righteous guitar shredding thing. But this is the video game version.
I remember the NES game. Is this the NES game, or is this a coin-op?
I pulled it off the coin-op, but I know that almost all the computer versions and console versions had similar music. Maybe not in its full, whatever it was, 8-voice majesty.
Right. Well, this is back when you would have cartridges that you would buy and put them into a game console. And I didn't have the cartridge, but my friend did. And I remember after school just going and watching him play the entire game through. Because he's like, I beat it. And I'm like,
yeah, right?
Didn't. Yeah. And that was like something you did. Like, you didn't go on Twitch and watch people play. You actually went over their house and you sat there while they played the game.
Yeah, well, back then for me, this game was in arcades and it cost $0.25 per life. And this thing is just, it's not a very good game. It's just, you sit there and you kick a lot, right? You just sit there and you kick, and you run around. And there's not really much skill. It's just mash that button and keep feeding quarters in. And I never really appreciated it till I built a RetroPie console, actually.
Oh,
and
right.
I've been playing it there. And, you know, it doesn't cost any quarters anymore. So you just keep mashing the quarter button and the kick button. So I finally played it through a couple times and actually play it with my son. It's a good intro video game for people who are really good at mashing buttons.
I remember swimming around in the underwater sewers with those plants that would electrify.
Ooh.
Is that a different game?
That must be a different game.
That might be a
sounds
different
awesome.
game. Oh, it was so hard. It was so frustrating. Like, you couldn't get through it without dying, and I'd always die.
Anyway, like Mike said last week, this is one where you either know it or you don't, and our listeners either knew it or they didn't too. We got 11 answers, of which 10 were right. So basically, everyone who knew it wrote in, and one other guessed a soundtrack from a Mega Man level, which is a pretty legit guess, frankly. So 10 right answers suggests instantly a 10-sided die. So today's random number is 7. Congratulations, Olive Garden.
Oh, wow. I didn't know corporations could win.
It seems to be someone's nickname.
Ah, okay.
So, man, Nate from Chile, from Detroit, you are going to win one of these times, man.
Does you keep getting it right?
You keep writing in with the right answer. I swear you're going to win. And we're going to have to mail it to you either in Chile or Detroit.
Maybe we should figure out, like, for the year-end show, we'll go back and look at the people who had the most right answers without getting drawn randomly.
Yeah, absolutely. Who had the most right answers to the contest? Oh, that's a good idea.
Yeah, so don't despair. We got your back. We're working on plans.
Exactly. So congratulations to Olive Garden for the win. And next week, I'll come up with something that's a little more hackery and a little bit less video gamey, so that those of you who didn't waste your youth throwing quarters into bright blinky boxes won't feel so left out.
All right, Elliot, let's jump into the hacks this week. What do you have on your list first?
My first hack this week is a video from serial awesome hack maker Matt of DIY Perks. I swear he just makes these projects with fit and finish turned up to level 1000.
Museum piece.
Dude, it's crazy. This one is cheap DIY mic, sounds and looks damn good. And you might be tempted to think a microphone is a simple thing because, it's just a microphone capsule that maybe you can just buy off the shelf. And then what else? There's stuff that holds it so that it doesn't just float in midair. And there's maybe an amplifier. And that's basically the whole deal. In some sense, that's true, but then all of the devils are in all of the details, and the difference between, a $3,000 mic and a $300 mic, and in this case, kind of a $30 do-it-yourself mic, should be audible. Although he gets a phenomenal result out of this one, and you can too. He does a lot of brass rod bending and stuff like that makes it look really awesome. But what I liked most about this build was actually the kind of super good design. He builds basically the simplest possible amplifier circuit that could possibly work at all and just kind of relies on good components where they're needed. And that is, in this case, a power supply, the DC switcher that gets you a nice smooth plus and minus 15 volt power supply, and then just a stellar amplifier. And this is that audio 1512. You couple those things together, and along with a good microphone capsule, and then you try to make it not vibrate, and you win.
I love the fabrication on this one. There are so many good tips in this, but the thing that I took out of it is maybe I can finally justify getting a creme brulee torch. Because he shows making a brass ring out of some flat stock. And
right?
Because he says it's home weldable, and he shows that you can do it with your soldering iron, and I've got a bunch of soldering irons I could use for that, but wouldn't it be more fun to get a little butane handheld torch?
You have to get yourself a butane handheld torch. For a while, we got rid of all the matches in the house because we had a small kid, and there were a couple times where I lit birthday cakes with a butane torch.
Yeah.
And that is awesome. But it's also really good for, like you say, for sweating joints and for brazing stuff together. Speaking of brazing, he builds a lot of this stand out of bronze rod, but then he also makes a really nice cage out of some, I guess it's a brass meshy stuff. And the cage around the microphone capsule is actually super important because A, it has to let the sound in, but B, it has to keep the electromagnetic waves out. And the other really cute thing he does for keeping the electromagnetic waves out is to use desoldering braid as kind of a cable shield to make his own shielded cable for one part of it. I think he just does it because it looks cool. When you take apart one of those shielded cables, what is it? It's basically silvery desoldering braid. You got some desoldering braid on hand, you can make a shielded cable. I love that bit.
I'm really kind of shocked by that because I don't think... Well, I don't know. I have to go look at it, but I have never noticed that my desoldering braid is actually like a flattened tube of mesh.
I think it's the other way around, right? I think the desoldering braid folks, I think they sell you cable shielding for quite a markup. So I've noticed, I went looking up the microphone capsules he used here, and they're all sold out at the moment.
Aw.
I think this is the YouTube effect. I think he suggested a really awesome hack, and they are currently bought out. But they'll make more, and there are other similar microphone capsules out there on the market. This one, I will say, sounded really good. I might have to make me one of these, and we'll see if that can replace my normal podcast microphone.
Where you live, Elliot, if you go and get drinks to go, and you get more than you have hands, so if you get more than 2 to-go cups of coffee... Do they give you one of those dingy gray or brown trays that you can put the cups into to carry them on?
That may be an American thing.
Yeah, and it's 100% recycled material, right? So it's kind of like one of the last life cycles of recycling pulp material. And this next hack is how you can make stuff out of that same kind of material, which I don't know why I'm excited about, but I kind of am. Especially because I am sickened by the amount of cardboard that we go through at our house. And the majority of this is virgin cardboard, right? I've long wished that we could get away from the cardboard. But if you can't get away from the one-time use cardboard, the next thing you could do is try to do something else with it. And in this case, they are printing molds that you then take cardboard pulp and binder and put them in and clamp them together to squeeze the water out, let them dry, and then you pop out this newly shaped item of yours. And so here there's like a pen holder, or it could just be a vessel with a little lid on it. You could do drink coasters, which I think is pretty cool, or whatever your heart would desire. And it's all by a hacker that goes by the name of Flowalistic.
Yeah, I think we've even seen some of these hacks before, maybe a year or two ago, and this one is kind of the refinement of this procedure, and it's gotten really good. I love the 3D printed molds and how they were built in multiple sections to make them easier to take apart, of course, but then also reinforced here and there to allow them to handle the pressure that you have to put on this thing, I guess with a big C-clamp here, to compress the cardboard together and squeeze the excess water out. And I think that part of the design of the object is actually the part that's really interesting to me. I think it's awesome to reuse the cardboard, but I think it's even cooler to, think about how to 3D print these crazy presses to make the cardboard object in the first place. And he's got a few really good examples there.
For the raw materials, it's pretty simple. You take a blender that you're not going to use for milkshakes anymore, and you kind of chop up your card. You got to take all the plastics out. So you got to take the packing tape and labels and stuff off. But right. you chop your cardboard up into like bite-sized pieces, I think Christina said in the write-up, and chuck them in there. It's about, by weight, 74% water, 22% cardboard, and 4% binder. In this case, PVA, which is also known as Elmer's white glue. Yeah, and then you run your blender until you get just pulpiness, and it's going to come out being a sloppy mess. You can put it in cheesecloth, squeeze most of the water out, and then take the mud that you have left and chuck it into your 3D printed mold.
I wonder if you couldn't use a waterproof glue to help out with this, because one of the things that Flowalistic runs into here is that the resulting cardboard isn't waterproof, and so you kind of have to shellac it or coat it with something if you're going to get it in contact with water. I wonder if you could use like a Tight Bond 2 or some kind of similar glue that's also okay with being waterproof.
Mm-hmm. Yeah, I'm sure you could. I mean, especially if you're using it for something that should be reusable. For me, I was like, this would be awesome for coasters, because you could have Absolutely. Like embossed with your family seal coasters. And then I was like, well, you kind of want coasters to soak up the sweat from the glass, though, right? Because if your coaster doesn't soak it up, it'll pool up and then run onto the table, which you're trying to protect with the coaster. But I was thinking, if you really needed it to be waterproof, you could just get a pan of wax and just give it a really thin wax coat.
My next hack is going to be a twofer. This is the week where we got 2 filament dryer hacks in 1 week, and I just have to cover them both. First up is most FDM printers are also filament dryers with a little help. This is a sweet little hack by Design Prototype Test. He builds basically a tower with a fan on top. The tower does double duty as a stand to put a spool of 3D printing filament on. So you put it on there, the fan sucks air up through the middle of the spool and circulates it around. You put this on top of the heated bed on your 3D printer, so you have a source of heat at the bottom, fan moving the heated air around, and then you put it all inside a cardboard box or something else to keep it insulated. And so you get moving heated air all the time, drying out your filament on something you already own, that is, a 3D printer. I think it's a really clever idea. Watching the video, you can see whatever, he must have a real name, of Design Prototype Test, doing a lot of research and looking at other filament dryers and coming up with the solution. I think the one he came up with is really pretty good. He puts a IR camera on it, and you can see the way it's sucking air across the heated bed from the cold spots on there. And I think you could optimize that out a little bit more. But it looks like a really sweet idea. And if you've got some filament you need to dry out and your significant other won't let you put it in the oven that you otherwise use for food, this might be a good hack for you.
I liked the beginning of the video when he's going over all the different commercial options for drying out filament. and basically showing that there's no secret sauce. It's just a convection oven,
Yeah.
all of them. I was wondering though, what's happening with the moisture, right? So you're heating up this like enclosed bit of air in order to get moisture out of the filament, but you're just like making the air inside more humid, right?
I think the use of a cardboard box around it provides a semi-permeable membrane that lets the moisture out.
I'll go with that.
I just made that up.
I'll accept it.
Which brings me to the second drying out your filament hack. This $0 filament dry box needs nearly no parts. And this is a sweet little hack by SpaceFan. The idea here is that your filament already comes in a bag with some desiccant in it. You just need to keep the moisture from getting in there in the first place. The print here is a little screw together grommet thing that fits around the filament, so it lets you draw the filament out of the bag without putting a big hole in the bag and compromising its moisture proofness. I do worry about how much friction that, the whole assembly, but in particular that little grommet thing is going to have on the filament you're pulling out, and I might overtax your 3D printer's extruder motor, which makes me, of course, think of all sorts of more crazy and elaborate solutions like external motors and maybe one that senses the tension on the filament and, pushes it along when it needs a little extra shove.
You're talking about a pre-extruder, and I endorse that idea. I think you should start building one.
Second extruder to extrude for your extruder. Yo, dog, I heard you like extruders. But I think the other thing you could do, of course, is just pull out a length of it that's about right and not worry about it. And I think that's actually the proper thing to do, especially since basically every slicer on the market says you need 2.5 meters of filament for this print. You could just by hand go pull, and call it good. That's what I'd do.
Elliot, I am a sucker for a clock. And so when this one came up on Hackaday alum's website, Limpkin, I had to grab onto this with both hands. It is the most amazing Nixie clock, not because it shows the numbers, but because it takes every little minute on the hand of the clock, all 60 of them, and turns them into an IN9 Nixie tube bar graph. All of this is held in place by a beautifully machined faceplate and driven by some really interesting custom electronics.
Pause now, look at the video, and come back later, because this is a fantastic piece of art as well as a clock.
So the biggest thing about this is that you need to give a variable voltage to each of these bars. And so what you want to do is you want to PWM the signal that you're sending to them. The problem is you have 60 of them. So how are you going to do 60 PWM signals with any reasonable level of resolution? And so Limpkin grabs an FPGA because parallel hardware is the way to go in this. That kind of solves the bigger problem. It is also driven by an ESP8266 microcontroller because the clock project was started 5 years ago. I totally get that.
I see how that happened.
Yeah, I can sympathize with that sort of thing happening. For me, one of the really, really interesting parts, I'm so glad that Limpkin included this in the write-up, is that they didn't work right away. And so I love to read the fails. Because these tubes were manufactured like 40 years ago, potentially, they've just been sitting around, and that causes some problems. And so in order to get them going again, a burn-in phase of 10 hours at the max amperage, which is 12 milliamps, kind of got them going again. And then also a 10 hours at 1/20th duty cycle at 50 hertz was the other thing restorative that was tried. But still, even with that, about 25% of the bar graphs that were soldered in just weren't usable and had to be replaced.
That takes one of these projects that's kind of monumental and makes it 25% more monumental.
But if you click through to the actual write-up project page on this, and you'll see at the top there's a animated GIF of what looks kind of like a snail shell going around. And if you look at it, you can see both the color variation, like the intensity of the color variation, and then also like the height at which the bar graphs will go out. And it, I think, gives a lot of character to this. Like if each one of these worked exactly the way that you wanted, it would just kind of be too precise and would lack that kind of like analog beauty.
Sure, might as well be a computer display at that point. No, this thing is fantastic. I think the clock is a red herring here. I think this is an awesome piece of kind of art. Like, I would have a field day just trying to think up all the crazy different animations you could make for this. And I'm glad you mentioned that seashell one. He also does a fast Fourier transform on it, and there must be all sorts of things. And of course, because it's round and it's got 60 different elements, it makes you want to do something that's repeating or cyclical. Oh man, I would lose weekends coding up stuff for this. Does he have a simulator so that you can do this on your own for the computer?
Oh, it would take you an afternoon to make an emulator on this, no problem.
Yeah, and then you could have other people design cool art for you.
And then you put a webcam on it, and you get even more people because they can try and run the code that they write.
Then you put it up on Twitch, and you can have people, I like the way you think. My next hack is Max V. Fisher's DIY CNC uses lots of 3D printed parts. And this is a CNC router that's derived from the one that Ivan Miranda made on his YouTube channel. This write-up, however, takes it to the nth degree. It's all done in a GitHub repository, and you absolutely need to go check up all of the different parts of it if you're interested in building a CNC router type machine of your own. This is an insanely detailed write-up. Like, every screw hole drilled and tapped is shown here. The frame itself isn't really all that complicated. It's just a bunch of 30 by 30 millimeter, kind of inch and a half square aluminum tube, and it's all put together into a right angle frame with a few 3D printed parts here and there that hold it together and do some of the hard stuff. I particularly like the Z-axis on this design, and I'm particularly questioning the kind of Y-axis 3D printed sliding cheeks. And if I made this thing, that would be like the first part that I would bootstrap into aluminum, because it won't be able to resist much force in the X-axis direction because it's got, bendy plastic. Although there's a video demonstrating him moving through some pretty decent quality plywood, not at super fast speeds because you don't want to load it down too much, but if you've got time, you can use this machine to make the next better parts anyway. So, in that sense, good on you. What I love here, though, is just the insane amount of documentation. If you're thinking about taking on this sort of build yourself, this will either scare you straight and you'll turn around and just go buy a CNC machine, or it will give you the most detailed roadmap you could possibly hope for to find your way through the forest.
I just like seeing the synergy of 3D printed parts and stock materials, because everything from like jigs to, grommets to protect wires and enclosures to brackets to hold things in place is done really well, but I wouldn't say overdone. It's not like, oh, I have a 3D printer, I'm going to 3D print everything, or, oh, I have a mill, I'm going to mill everything. It's like kind of the right choices at every step.
Even if you're not going to build exactly this same machine, the things you can take away from this are all of these kind of little clever solutions to similar problems that you will have even if you're doing a different design.
My eyes popped out of my head when I saw this huge RGB LED Cube project this week, Elliot. I gotta say, I haven't built a cube. I've seen them. They're interesting. But there's a point at which you look at a project and you realize there are thousands of LEDs in it. And you're like, the difficulty, the pain of building this thing is incredible. And once you start looking into this one, he engineered the crap out of this. This is a project by Malt Whiskey that takes a 16 by 16 by 16 cube. That's 4,096 RGB LEDs, puts them up into what visually to your eye is a immaculately perfect grid that makes them look like they're hanging out in space because it's very fine wire that's supporting them, and then puts them inside of a jewel case of acrylic that surrounds the thing, and then runs all kinds of different volumetric full color patterns on it.
You said you haven't built an LED cube. I have. Mine's 4 by 4 by 4, and I was thinking about doing a 5 by 5 by 5 at one point, and I'm like, exponentially more. No, That's just too many stupid LEDs. And this one is then 16 by 16. Yeah, the mind boggles. This sort of thing used to be even 3 times crazier a feat back before they invented these kind of addressable pixel LEDs, right? And so the one thing that he's got going in his favor here is that he doesn't have to drive a red channel, a green channel, and a blue channel for each LED, but they're daisy chainable together just like the WS2812 LEDs are or whatever. Except these look like they're individual 3-color LEDs. They just don't have all of that pesky wiring. Although he still has to make sure that the ins go to the outs and the pluses go to the pluses. And
Right. Well, I think so. This one's actually got the PL9823, which is a clone of the WS2812, but molded right into it, and it reduces the number of pins that you have, but not by enough for it to really make the mechanical fabrication of it. So for instance, if you have a 16 by 16 grid of LEDs on the top 16th level of the cube, how do you get signals to all of those, right? You got to run down the columns to the base of the thing. And so this makes it so that you chain from one to the next. You have serial data traveling. And that's actually how Malt Whiskey did it, is by making them in columns. Let me see if I can figure this out. It must be 4 by 4 by 16 columns. By making them that way, you just have the data kind of going up. And in order to get the precision here, this project is really all about jigs. And so there's a jig for putting each LED in, and then with the legs sticking straight up, and they have like a little notch cut out for the flat side of the LED that indicates the polarity. So you always have it oriented the right way. And then these 2 little doors that snap on that let him bend the pins over. So the 2 inner pins one gets bent left, one gets bent right. And there's little clips on the 3D printed, top plate that he snapped on that those legs snap into. And then you cut them off right where they snap in so that they're, 1 centimeter long. The outer legs, I think, stick straight up. And there's these little nubs that raise up on the doors so that you clip them just to the right length. And so you do this 4,096 times and then put them all in a bin. You go to the next jig, which is for like 1 layer 16 by 4 of the LEDs. And on this jig, it's got these rails for putting the bus wires for transferring data from one to the next and power from one to the next, because you can't just like power everything from one source. It's like way too much current. And then in the video, you can see all these red, black, and green lines that are drawn on this jig to make sure that everything gets, put in the right orientation and going the right way. These all go onto a PCB that's in the base and delivers all the power. And then in order to make sure that each of these 4 by 4 by 16 towers actually lines up and isn't like out of whack, there are screws at the corners of each of the PCBs to kind of, you could tilt them front to back or left to right in order to get them to line up.
He points out in the video that the only way to keep his sanity during this whole thing is to do it in these modular towers, like you said, and that way you can build one, troubleshoot it, and then build the next one, troubleshoot it. Can you imagine if you soldered this whole thing up and you had a problem somewhere in the middle, like, in pixel 8 by 8 by 12 or something, and you have to dig down to the bottom and resolder it? No.
I don't know if we said it yet, but this thing draws 1 kilowatt of power when everything's lit up to all white.
That's ridiculous. You could heat your house with it.
Ooh. That's another selling point for being able to make this. On the way out, the last thing is, of course, people are wondering, like, what would it take for me to build one of these? And we were, someone says, oh, this is thousands of dollars in LEDs alone. And then, Dave Roundtree, who wrote this article, pops in and says, I wondered this myself because I wanted to build one. And I think I could get the LEDs for $600.
My first quick hack this week is streamline your SMD assembly process with 3D printed jigs. This is Igor's project to make a jig that fits exactly your odd-shaped PCB, and it does this by using OpenSCAD to take a Gerber or KiCad design in, spit out exactly the right size stencil frame, and then you slip in the fabricated metal stencil. it clicks it all together and you can fit it down precisely where it belongs. This is a genius use of the common tools that we all have around us. Next up, development of magnetic locking idea shows great progress. This is a demo video by the Action Lab. If you've tried to hold two magnets together and have them like float in midair, the secret is that one of them has to be an electromagnet so you can turn it on and off, because you can't do it with static magnets. Or can you? You can if you're willing to spin one of the magnets. And the gimmick here is that it spins faster than the angular momentum can change on the other one, and it ends up levitating two magnets, one with the other. You just have to watch this video. It's a really interesting and I believe novel construct. What is it? It's a novel idea that Action Lab learned about from a Turkish YouTuber, Hamdi Ukar. Last up, Pokemon Time Capsule 99432463667. You're killing me. Replaces the RAM on a Pokemon game. Apparently the problem is that old school Pokemons have SRAM and require power to keep their memory alive. He replaces it with FRAM, Ferroelectric Random Access Memory, which is this kind of weird fringy RAM. It operates like RAM, but when you turn the power off, it retains its state. These are fun little chips, and I've always wanted to know what the right project for them is. The answer is making a Pokemon game that doesn't lose your critters when it loses power. The comments here are full of lovely reminiscences about Pokemon. Some guy in particular had transferred his Pokemon to Pokemon Stadium, was able to dump the ROMs. He ended up typing the binary into another game by hand and had Pokemons from his childhood back that, as he says, were old enough to drink.
First up on my list of quick hacks, Flip Dot Oscilloscope is flippin' awesome. Adam Zaloof wrote this one about a project by BitLooney, and it's exactly what it sounds like, a flip dot display. Those mechanical displays that have tiles that are yellow on one side and black on the other has been connected up as the display of an oscilloscope. It draws a waveform. It is the most pixelated waveform you'll ever see on an oscilloscope, but it's a ton of fun to watch the project come together. The metabolizer is turning trash into treasure even faster now. Christina Panos has been following this project for a couple of years, and it is a real delight to see what you can do with, I guess, all renewable energy. It starts off with solar power that is used to turn biomass into fuel for a gas generator. That gas generator then powers machines that chew up plastic trash and 3D print it back out again. And finally, reballing and a steady hand makes a Raspberry Pi 800. Jenny List grabbed onto this one, which is the Pi 400, that keyboard form factor Raspberry Pi, but given 8 gigabytes instead of 4 gigabytes of RAM. It appears you can order these chips if you know where you're looking, but being a little bit anxious to get the project done, a donor chip from a Pi 4 was taken. It had to be reballed manually in order to be put back onto this Pi board, but it indeed turns it into a Pi keyboard with twice the RAM. It's time for our Can't Miss Articles of the Week. This is long-form content written by awesome Hackaday writers. Which writer did you choose this week, Elliot?
I'm cheating. I picked 1.5 articles this week.
What?
I'm starting off with Tom Nardi's teardown of the analog radionic analyzer. And normally our teardowns are really technical, and it starts with him taking his screwdriver. This one starts with a story, and I just thought it was so sweet. This is the collection of an anonymous donor who had seen some of Tom's crazy teardowns on Hackaday and thought that they would give him their collection of paranormal, spooky, hokum, snake oil devices that their parents had collected. And Tom, of course, is like, oh, bring it. And in this case, he takes apart one of the first of these, which is, of course, a radionic analyzer, which allows you to, by magical radio waves, reform matter itself. And it's got this like sample well that you put the thing you want to radionize into, and then you turn some dials, and they're these lovely old Bakelite dials with blinking lights and everything. And of course, you know it's a scam device. And so Tom opening it up is just as anticlimactic as you would expect it is. The inside is like some wire and some hot glue and not even a 555. It was some other LED blinker circuit I see. It's all smoke and mirrors, folks, except they're these really awesome 4 air capacitors, like from old school radios for tuning this thing to make it blink at arbitrarily different frequencies to fool the user, I guess.
I mean, you really have to look at this and put it into the time period that you would have had these things. Like, I think personal electronics are everywhere in our lives now, but that's a rather new thing of the last like 15 to 20 years. Before that, you would be looking at like clock radios, transistor radios, I guess kitchen appliances. There wasn't a ton of electronic stuff that you would own. And so when you get this and it has these, graduated dials on the front of it and switches, and it's in this like industrial looking controller and it's got an appliance cord on it, you might, look at it and be like, oh, this is something. Like, people don't have this sort of electronics. This must do something important.
I mean, it does actually some cool things. The sample container is a PVC pipe end. Actually, it's a pipe fitting, but they've wrapped some coils around it. So it actually does kind of work as an inductor. And if you put something metal in there, it will change the frequency that the LEDs are blinking at. So, that's actually kind of a cool design element. I don't think this thing's as old as you think it is, Mike. I fear this might be 80s or 90s.
I was thinking 80s. I mean, how
stupid were people in 1980? I was there.
Well, I mean, you had the clapper, right?
Right?
Clap on, clap off, the clapper.
Yeah, but that worked.
Right, but I'm just saying, like there wasn't a lot of electronics that yet out there. Like, it was pretty limited in like personal electronics that you could have. You had tape deck. You had a Walkman.
Which is a million times more interesting and sophisticated than this thing.
Yeah. Okay. I'll give you that.
We've actually got one of these hoax devices in our basement, and I left it there because I love the thing. It runs on a 9-volt battery, and it's actually got a 555 in it. And it's got a little light that blinks on and off, of course, and a dial that you can change the frequency with which the light blinks. And then it's got some coils that go out and they wrap around one of them's red and one of them's blue, and they wrap around the water pipe going into your house. And it's like Dr. somebody's magnetic something. And I left it there because I figure, whatever it's doing, we got to keep that magnetic something happening to our water, right?
That's a structural poster moment, right?
Yeah. But our house was built in 1992, which means that
oh man,
the owner was fooled by Dr. somebody's whatever machine in the mid 90s, which is just a little embarrassing. Anyway, the point is there's a sucker born every minute, but it's awesome to tear down the devices that we use to sucker them.
And it's awesome to know that there are years worth of these teardowns incoming.
Ooh, I hope so. And I just wanted to give a super quick shout out to Chris Wilkinson's Weird Al's Monster Battle Station is now just a reasonably fast PC. If you haven't heard Weird Al Yankovic's takeoff of All About the Benjamins, All About the Pentiums, you absolutely have to. It's fantastically hilarious, and Chris loves it as much as I do. In this article, he proposes, what would it take to actually build this like nerd geek flex computer that's proposed back then in must be 1999. Anyway, that's good fun. Some of our readers took it on themselves to do that as well and try to make it even more factual. I just love this Weird Al song. You have to go listen to it if you haven't in the last decade.
This week I chose an article by Robin Curie, Smaller is Sometimes Better, Why Electronic Components Are So Tiny. I love this one, Elliot, because he goes into a lot of really interesting detail on what are the limiting factors on making things smaller and smaller. He starts off by saying, everyone knows what Moore's law, and that is like the number of transistors on integrated circuit doubles every 2 years or so. And, there are all kinds of arguments on whether Moore's law is dead or alive, but Moore's law doesn't really matter to me. What matters to me is like why. And this is the article that you definitely want to read on that. Smaller gear uses less power, and it's got higher resolutions because of that, and it makes more room for other stuff. So if you think about like the power budget in a device that is by its nature using less amperage in every calculation that it does, means that you might expand and say, oh, you know what, we have the space on the die to put a MEMS accelerometer in there and to power it, and so that's going to be part of this device. And I think you just get all the extra bells and whistles because of the increases in efficiency and the reductions in size for this thing. So where is kind of the limiting factor? Like, what is preventing that from going faster? I always think of heat, but one of the things isn't just heat, it's actually the size of the transistors. And so as the transistors get smaller, you have less of a problem with heat. And that made me think about it like, well, how many transistors are we talking here? So the M1 processor that Apple rolled for their own devices recently?
Sure.
16 billion transistors in that thing. So like the most marginal of marginal improvements in power efficiency and heat dissipation have an incredible multiplier in that number.
That is the truth. And these chips end up using a lot less power. I was waiting for you to say the magic word, parasitic capacitance.
Yes.
The important physical property here is that as you make things smaller, the leads going into them and the wires going into them have less and less a capacitance with the substrate and with each other. All of these otherwise unnecessary parasitic capacitances get smaller and smaller, and these are like fake capacitors that you have to charge up and discharge every time you want to switch the transistor from on to off. And so most of the energy in switching state on these goes into overcoming this parasitic capacitance. So the smaller you can make the transistors, the less of this you have, the less power the transistor takes, the more energy efficient the whole darn CPU is. And so that's a huge selling point of miniaturization for things like transistors in ICs. And then he goes on to say, well, is this the same in discrete parts as well? Does this also hold for, the ever shrinking from like 0805s down to these like tiny 0000 parts that I can't even see anymore? And the answer, of course, is a mix. Like the capacitance relies on two surface areas next to each other. So as you shrink the parasitic capacitance in the transistors, you're also shrinking the capacitance of physically smaller discrete capacitors. And so it's harder and harder to make a bigger capacitor smaller. But you also get these other advantages like shorter distances between the leads. So there's less of this kind of weird inductances and things. And he draws, I think at the very end, something that me as a kind of radio-affine person thought was really interesting, which is that this also goes hand in hand with the kind of move toward higher frequency stuff, in particular with radios, but just general processing speed as well. Less parasitic inductance means you can use higher frequencies. Higher frequencies means you don't need such bigger capacitors in the first place, which means you can get away with smaller capacitors in the first place, which means you can use tinier pieces. And this makes me think about, how radio design, doing this ultra high frequency stuff used to be impossible 20 years ago, 50 years ago. And now it's just a matter of getting a bunch of 0402s, which are a pain in the butt to solder. You can solder these things together, and you can build 900 megahertz devices, whereas just the lead length of a through-hole component would prevent you from being able to do it not very long ago.
Well, I think that kind of brings us into what really is the dark art of all this. And I'd love it if Robin would write another article on this. So he talks about how as we get smaller and smaller, especially with the silicon design, you actually have the circuits start to behave differently because quantum mechanics comes into play. And this is something that is, if you thought high-speed switching was, a difficult thing to design around, imagine that your circuits actually start to behave differently. One of the things I've always had on my mind, Elliot, is, those movies where they're like, we're going to shrink people down inside of this ship and then send them into the bloodstream of this patient and they're going to go and explore their body. So what if you had a shrink ray like that and you had your cell phone in your pocket and then they shrunk you down like what would the behavior of your cell phone be like? Like what would happen to the voltage levels of the battery if you took the same battery design and just shrunk it down? Like it's an interesting thought experiment to look at it. And I think there are a ton of engineers who get paid bajillion dollars to kind of solve these problems and get around harder and harder physics challenges that come with the small scales that we're working on these days.
That's hilarious. None of the electronics would work, of course. Honey, I Shrunk the Kids. The whole plot is ruined for me now. Thanks a lot.
It's fascinating. I think you could get lost in this topic forever, and it's well worth your read this weekend. That is it for this episode of the Hackaday podcast. Tom Nardi will be in for me next week because I am in the final shoot of getting ready for Hackaday Remoticon. We want to see all of you there, so go grab a ticket, remoticon.io. If you wanted to comment on this episode, you can leave a comment on the show notes, which you'll find at hackaday.com/podcast. And until next time,
keep on hacking.
Dun-dun-dun. Is that who does Eye of the Tiger? Dun-dun-dun.
I thought it was done by what's his face, Rocky Balboa. Wait, that wasn't Eye of the Tiger anyway, was it?
What is it? What are the lyrics?
Getting stronger. I think. Dun dun dun. Dun dun dun.
Dun dun dun. That's what it is.
There you go. That's Eye of the Tiger.